Welcome to The Healthy CEO, the show where we dive deep into the science of longevity, the art of health span, and the strategies that help high-impact leaders live and perform at their best. I'm your host, Jason Wright. Each week, I sit down with world-class physicians, wellness innovators, researchers, and entrepreneurs who are reshaping what's possible in human health. From breakthroughs in cellular optimization to metabolic health to the habits and mindsets that drive extraordinary performance. This is your front row seat to the future of well-being. Today's episode is brought to you by Authentic Health, where we believe your body deserves more than minimum viable nutrition. Our foundational supplement stack, developed by Dr. Gus Vickery, a physician with more than 30 years experience, is designed to support cellular energy, metabolic efficiency, and total body resilience. If you're ready to take a smarter, more personalized approach to your health, visit shopauthentichealth.com and explore the tools that can help you build a stronger, longer lasting you. Now, let's jump into today's conversation. And remember, you don't just need more years in your life, you need more life in your years. This is The Healthy CEO. Thanks for listening. Welcome back, Dr. Gus. Man, it's been way too long since we've had you on any of our podcasts. So you're not only just, am I so excited to have you on, but it's good to see my buddy. It's been a while, dude.
It has been a while. We've both been busy, I think, doing hopefully, I think, positive things in our various, areas of application, industry, et cetera. But it's been too long.
It has been. So I'm glad that this is happening. And today we're going to talk about something really important, which is cell signaling. And I want to tell you why I chose cell signaling as something important. You and I talk a lot about how you have always, your kind of philosophy as a physician is to treat and manage at the cellular level, which is kind of what really drew me to you as a mentor and someone who took me to the next level in my understanding of health and wellness and longevity. And one of the key components to that I don't think, and maybe this is just your bumpkin buddy from East Texas not thinking about it a lot, but I think that I don't think I'm all that unique. I think that a lot of people, when they hear cell signaling, they're like, they don't even know what that means. They don't even have and so I know I had no clue. And so I wanted to do a really deep dive into cell signaling. So I reached out to you and said, hey, we need to get back on track. Let's do some episodes. And this was the topic that I wanted to discuss. And let's just start kind of at the macro level, if you will. So for the listeners who have never heard the term before, what is cell signaling and why does it matter for everything from energy, which, like we were just talking about, mitochondrial health and the power generation of our cells, to longevity? What is it and why does it matter, Gus?
Yeah. So if a cell lived in isolation, and there are single cell organisms on the planet, then the only signaling that would matter is the inputs that cell was receiving from its environment, and then how that would impact its internal shifts in terms of DNA expression or RNA expression, the proteins and enzymes it makes. But in a human being, our cells don't live in isolation. They live in networks. They live in their first network are the organ or tissue that they're derived from. So liver cells or kidney cells or brain cells or heart cells or muscle cells. And then, of course, they're networked with the entire system, meaning that the liver is talking to the kidney and the kidney is talking to the heart. Like everybody's talking to each other. And the ability for that signaling function to be accurate, right? Like an accurate representation of what's actually happening, which are inputs from the outside. They're inputs from inside our body, internal things that are being produced. They're inputs from our thoughts and beliefs that actually affects the signaling. But for those signals to be interpreted accurately, for the right signals to be getting through in the first place, because you can have wrong signals going on as well, and then for the right processes to then be initiated in response to that signal, both in the individual cell for its own optimization of function, but not only but then its its cell cluster, meaning the tissue that it's in, so that they're working in harmony and that the liver cells are all doing what the liver cells all need to be doing at that given moment, but that they're also complementing what's happening in all these other places in the body. So this is an incredibly complex network. And if the signal pathways are disrupted for various reasons, then clearly things are going to go awry, both on an individual cell level, but especially on the network side, which is why things are, you can never look at biological models in a reductionistic way and say, oh, okay, I'm just going to address this one particular little factor and that's going to, take care of everything, or use this one pharmaceutical to treat a particular condition and that's going to actually fix it. So the signaling is critically important. Cells are constantly communicating within themselves and to their neighbors and to more remote locations. And those communications are determining how that biological system is actually adapting to the changes and the inputs and able to express the most optimal version of health that it can, given what it has available to do so.
Okay, and that leads perfectly, and you kind of touched on it, to my second question. How does signaling malfunction, how does it generally show up? You've seen thousands of patients. So how does it impact someone's day-to-day life, and what are some of the symptoms or patterns that you see when someone comes in and it's a result of this disruption in the signaling? What does it look like?
Yeah, so, and it could be any kind of disruption, right? It can be inflammatory signal that shouldn't be there, excessive oxidative stress or biochemical stress signals. It can be excessive nervous system signals for stress and threat and chronic nervous system arousal. It can be anything across the board, toxins that are creating abnormal signals. The expression of that is going to be somewhat dependent upon which pathways are disrupted. But in general, it's because at the end of the day, it all distills down to this one cell working among trillions of cells and all of their little mitochondria creating the energy and influencing this. What it looks like is a reduction in overall cellular function. What does that feel like for a human being? Well, it can feel like a lot of different things, but in general, fatigue, mental and physical. Now, a lot of people might think I'm not that tired, but they just don't know, right? Because they've adapted to the level of energy that's available to them, and they're making do with it, not knowing that they're working at 40 or 50% of the energy capacity they could have available to them. But fatigue, mental and physical, inflammation, meaning pain, discomfort, achiness, stiffness, just feeling like whether it's the musculoskeletal tissues or the gut or even the brain, because the brain can have chronic inflammation, that you have this sense of that the inflammation is hurting you, that it's causing discomfort. So that can, be headaches, that can be muscle aches, that can be joint aches, joint stiffness. Then the effect on the brain at a level of neurotransmitters from this is an imbalance in what are known as excitatory and inhibitory neurotransmitters, and reduced productions of like bliss and well-being neurotransmitters like serotonin, which ultimately are on the pathway towards melatonin in biology. So you get a lot of emotional potential symptomatology from this, melancholy, depression, anxiety, rumination and worry. And so in general, it presents like the typical patient at one of our clinics who's coming in for the first time because they feel like something's got to change. I'm mentally exhausted. I'm physically exhausted. I have brain fog. I'm having a hard time focusing. My nervous system feels edgy all the time. My sense of joy is blunted, meaning I'm more melancholy, more of a sense of doom. And this might not be a person that's clinically depressed that eats medication. And I just hurt. I don't feel good. My gut hurts. My body hurts. That's what it looks like.
So,
but it could be subtle, right? It could be just a very mild version of that, or it can be a fairly extreme version of that.
okay. Now, somewhere, I had this in my notes that you've said signaling is upstream of almost every chronic disease. So kind of talk about that a little bit, unpack that a little bit.
Yeah. So ultimately, the way we look at it is there's dysfunction and then there's disease. Now, when there's disease, there's always dysfunction, but you could have dysfunction without disease. right? So this is the body working with whatever it has to work with, all the various inputs that it has available to work with to generate its expression, right? Genetic expression, expressing epigenetic expression in health. And so once the body, if some of those inputs are faulty, meaning nutrient deficiency and insufficiency, which is one of the most common, you just simply don't have the essential molecules you need to run this system. High toxicant burden causing a lot of abnormal signal, the oxidative stress. Well, what that first leads to, and it leads to a lot of types of dysfunction, but the easiest one to talk about is mitochondrial dysfunction. That's like sort of like at the foundational level, your mitochondria can no longer function as they were designed. So essentially, in big terms, the efficiency, meaning if a mitochondria has a capacity to work to about 80%, meaning that there is a red line moment for mitochondria that you can't really, and what you're doing in the mitochondria real quickly is you're taking forms of carbon and oxygen and you're combusting. That's very simplified because you're actually creating an voltage gradient and all these things. But at the end of the day, you're combusting, which of course is creating exhaust. We'll just call it exhaust. These are oxidants, reactive oxygen species. And at the end of the day, your mitochondria could have the capacity to work at 80% of their build, but you're only able to work at 40% because it's limited. And if the mitochondria can't function well, then it affects a lot of things, not just available energy, but it actually affects signaling. It will change how the mitochondrial genes, if they're stressed, are actually changing your own genetic expression. And there's an interplay with the gut biome too, which makes this even more complicated. But at the end of the day, as the mitochondria become dysfunctional, then the cells that are dependent on those mitochondria also become dysfunctional. Now, you have your highest mitochondrial density in your brain, your retina, your heart, your muscles. And just as ovulating women actually have an enormous amount of mitochondria in their ovaries, whatever. But whatever the case, so we begin to see dysfunction in these particular areas, right? With whether it's the nervous system and the brain, mental fatigue, depression, and how the nervous system is signaling everything else in the body, cardiac capacities, cardiopulmonary capacities, muscular capacities, etc. These things are all affected by that. And so you start with dysfunction, meaning the system is not operating optimally. It's got real problems, but you're not actually in a state of disease yet where you could be diagnosed with an actual medical disease. But if that dysfunction goes on long enough, it eventually is going to lead to disease, right? And that's now at a point where your body has entrained into that dysfunctional state to the point that it's now affecting global function. Now, not every disease affects every system, but ultimately, if it's, say, the liver, and the liver has been under stress and you've got this chronic inflammatory process in the liver, well, then you begin to have reduced liver function. And then your ability to manage detox pathways, metabolism of hormones, medications, other things, and your ability to take nutrient components that came in through the gut and actually process those and send them out. All of that is compromised. And you can imagine the effect that would have globally on the system if you're not detoxing nor processing the essential molecules that you ate in a way that they're now usable by your cells. And that's just one example. And so once we get into a state of disease, now we're going to have to play a different game than we were playing at a dysfunction level, because at a dysfunction level, if you can fix those signaling pathways, then the body will then orient back towards normal health, right? Like that's what it wants to do. But if you're not fixing them, and now when you're in a state of disease, what's happened is the dysfunction is now entrained into that system. It could be in the immune system with an autoimmune disease, right? It could be into the mitochondria in the muscles and brain with fibromyalgia, or there's any number of things we could name. And at that point now, in order to get that system out of the disease state and actually migrating back towards a healthy state, you've got to do a whole lot more. Now, it's doable. That's something we teach constantly because we've seen these diseases reverse. It's doable, but it's a lot heavier lifting than fixing dysfunctional signal early and restoring normal function.
So, and I always need some sort of an analogy or something to help me understand. And I've talked about this before. The way I always look at the mitochondria is I compare it to a car and the
Mhm.
engine.
Yeah.
And so, and that's going to kind of lead into our next conversation, which is cell. And I want you to, and I'm asking for your correction here in the way I'm explaining this. So you've got two components that we're really going to target here, as it relates to cellular signaling and cellular health, for that matter. You've got kind of the cell membrane, the wall, the body of the car, how
Mhm.
healthy it is, and then you've got the combustible engine and how
Mhm.
well it's functioning. And in like the reason why we start with the mitochondria and making sure that it has the right inputs, it's healthy, because it's the thing that's going to drive. If it's not healthy, you could have a beautiful Mercedes G wagon that's just absolutely looks pristine, but if it's got a crappy engine in it, it's
Mhm.
not going to get where you need to go properly. And depending on what's wrong with that engine, it could cause a crack in the engine. Let's call that chronic disease. It could be something that, like what you've told me before, whenever you started teaching me about cellular efficiency, is that it might just be you need to shore up the exhaust system. If you
Yeah.
can shore up the exhaust system, then to your point, that energy to get to that red line, you've got a max you can get, but you're operating at 40% capacity when you got a delta of another 40 you could push, but it's not efficient because your mitochondria is not healthy. So we shore that up. Then we move to the body of the car, the membrane that protects the engine and kind of and has it's more of the structural. But we start with that mitochondrial health to make sure it's operating as efficiently as possible. We look to see if it is just something that can be patched up, and lifestyle change. Is it a genetic issue? Whatever the case may be, just to see why you have that disruption in your your cellular combustible engine that you would have in your car. You put it on the diagnostic test first, and then you start putting together applications to figure out how to reach health. Am I kind of
No,
understanding?
no, I use that same analogy a lot, and I think we've probably used it together. And the car has an electrical system, right? It actually is running things, and so there are a lot of components. And at the end of the day, the car engine, typically, provided that you've got money to buy fuel, what it's not running out of is carbon from petroleum or oxygen,
Right.
right? It's got that, but it can't convert that into your energy, and that essentially is something similar to what's happening in your mitochondria. And the shell, as you discussed it, um, this actually points to a kind of a flaw in how I was thinking about things years ago. Membranes were just thought of as membranes, as long as they were intact and able to basically protect the inside of the cell. Then we felt like, okay, the membrane's good. But what we've learned and through molecular biology and studies over the last really more than 5 years, really 10, 15, 20 or more, but really becoming applicable to what we can do in a medical clinic, is that membrane is actually very much alive and creating signal, and that the cell itself isn't just dependent upon the membrane being structurally sound and intact. It's actually dependent upon that membrane having the right composition so that it can manage signaling properly, so that the inside of the cell actually knows properly what's going on the outside of the cell versus getting flawed signals. And then inside your mitochondria, you actually have membrane complexes that are vital to the function, because even though you are essentially combusting hydrogen and carbon in the mitochondria, there's an extra step where you're taking the energy that's created from that, and you're separating protons and electrons across the membranes. And that's creating a gradient, an electrical gradient that can be released and then turned into usable energy. And if those membranes in the mitochondria have a crack in them, which is interesting you said that, because what studies were revealing is that at baseline, not all, most issues with mitochondrial function have to do with the integrity of the mitochondrial membranes. They're not healthy, and therefore you end up with excessive inflammation and chemical stress. And if you could look at it under a microscope, what you would see, the membranes have holes, little holes punched in them, cracks. So now the gradient, it's leaky, right? Like you can't create that voltage because it just
Yep.
leaks right back out. So rebuilding normal functioning healthy mitochondrial membranes is step one, with on the understanding that you're also doing the same things that you would do for that, pretty much what you do to build those healthy cell membranes. And in the brain, the membrane fluidity and flexibility of neuronal cells in your brain have a direct impact on overall synaptic activity, which is the communication of the brain itself, talking about signal. So if those membranes, like for most people, and I could show real quickly a cell membrane test and show you what it looks like in the average person, are too rigid and lack particular essential fatty acids, your actual synaptic capacities, your ability to process has just reduced by just that alone.
Okay. And that would be fluidity, right?
Yes.
So we're going to get to out. That's good. And the only reason I asked you that is to make sure I was tracking, knowing.
Yeah.
So,
Yes.
okay. Because we're going to get to that, because that's something that I think that I know that's something you talk a lot about. But one of the things I wanted to ask you, whenever you're talking about those holes in the mitochondrial membrane, is that, I've got two questions. Is that primarily, first question being oxidative stress that's causing those holes? And then two, is that damage mostly in your patients that you see, is it lifestyle or genetic that can cause that stress and that puncturing that leads to the poor signaling and the inefficiency? And I'm asking too many questions at once, but I know you got a big brain. You can stick with me here. If it's genetic, does that mean that essentially, can it still be repaired? Can you overcome that genetic disposition if in fact that is what it is, versus lifestyle, which is just, stop doing the stuff that's damaging the membrane?
It's a great question. The answer to the first part of that is that the vast majority of people I'm working with, it is primarily lifestyle
Okay.
that it's influencing it. Now, that said, there's a range of genetic potentials across our population. Now, there are some people who actually have significant mutational diseases that affect mitochondrial function. And those mitochondrial pathologies are severe, and they're very hard to treat. And it's a small percent of people, but nonetheless, the people impacted is significant. We're going to take those and kind of push them to the side for this discussion, because that's a different thing altogether. Then when we talk about genetics, we're talking about how robust are your genetics for different aspects. And these are not mutations. These are variants in genetics at a population level and, affecting individuals. And so how robust are your genetics for producing the antioxidants like glutathione, nitric oxide, catalase that are part of managing that oxidative stress environment and maintaining it in balance? Your genetics may not be that robust, meaning those systems aren't naturally robust. And given the modern environment and what it's doing with all the additional toxins that are damaging these membranes beyond simply the normal cellular exhaust that you would have produced, that all humans have always produced, then you may end up not having the internal capacity to manage that genetically. Now, we can support it, to your point. Then we can fortify those systems so that we can overcome that particular limitation. Or your genetics for particular inflammatory pathways may have an influence. So there's a whole hub of mitochondrial genetics that we can look at that get into what is the likely, quality, innately, and robustness of the membranes or the enzyme systems that are creating antioxidants, or the enzyme systems that are managing inflammatory response that will influence it. But unless you have the actual mitochondrial diseases, the genetics have an influence, but they're not a limiting factor. Meaning if you know them, then you can come in and use tools and resources to overcome those limitations.
So how would you find, would that be like epigenetic testing? Would it be like I know you do a lot of blood work, blood panel testing, and you look at those, like what would be the first step to try to get a baseline for where you?
Yeah. So our genetic evaluations look at these areas, right? Inflammatory genetics, detox genetics, mitochondrial genetics, and we can already get a sense of how well is the build. Now, some people might not have a great build in that area, but then they have great build in other areas, right? So it's always, a spectrum. You get some things that are great and come easy for you, and some things that you're going to have to work harder for. But even if I didn't have the genetics, I can pretty much tell from the other studies we use, metabolomics, which are looking at biochemistry and a lot of specific domains of mitochondrial function, oxidative stress, membrane, citric acid cycle, et cetera. And we're looking at a lot of other things with metabolomics, looking at their toxicant panel, looking at their blood testing. Then you can pretty much know that the average person living in the United States, unless they have been already deeply like using a precision health model to program their health, that even if you don't have their genetics, the system is going to be impaired, because that is the current status quo for our population living in our country because of food quality, air quality, water quality, excessive stress and demand pressure, screens, disruption of circadian biology, and many more things. So the system is starting already with a lot of limitations, regardless of your genetics.
Okay, and so that brings me to another question, and I know we don't ever, thank God for the primary care docs. You've been a primary care doc for going on 30 years. That's now focused more on functional integrative health and more keeping you well versus treating you if you're sick. Although I know you treat people when they are sick or have deficiencies. If someone goes in because lacking energy, something's just off, and it is this. It could be with the proper testing and evaluation understood to be a genetic malfunction or something to that effect, could be treated. Is the normal protocol of someone out there, a primary care physician, going to be to go into this sort of depth to figure it out, or is it going to be more of a diagnose and prescribe situation? And the reason I'm asking this, Gus, is not to give you to throw you a softball for all the reasons why integrative health is so great and because that's what you practice. But I think a lot of people out there listening to this, as much as you and I live in this world of integrative health and wellness and longevity and health span, a lot of people out there are still like, wait a minute, I go to the doctor if I'm sick, and they don't know the difference between standard primary care and integrative health. And so my question is, everything that you've just kind of walked through, kind of that path you would follow to determine why you're having the disruption of the mitochondria. Is it genetic? Is it environmental? Is it something that you're consuming? Is it behavioral? Is that just normal protocol to discover that? And the answer may be yes. I honestly don't know.
No, it's not. And I can't speak to exactly what other primary care doctors are doing in their clinics.
Right.
But I still, in a sense, do primary care for my patients. But I think it would be a reasonable assumption that a curious, well-educated primary care doctor, when that person comes in with, say, a pain syndrome and a weakness and a fatigue, is first and foremost doing a really good inventory on all the various symptoms and history. And first surveying in their own mind, does this fall into a diagnostic box? Because if it does, then I might have some good studies telling me which medications or which lifestyle interventions have been shown to benefit it, and I'll advise it. If it doesn't fall into that neat diagnostic box, then they might throw out a net and test some things, hormones, things like that, to see, okay, are these contributing factors, inflammatory markers? And they may or may not find a pattern to them that stands out to give them more guidance. Now, usually what they're going to do then is say, what does this most closely approximate in terms of a diagnostic box, and what would be the tools we would use? But most of the time, it'll be biased towards a pharmaceutical that might influence the symptoms. Now, I still use pharmaceuticals in my models. They can be great, but they're not fixing root cause. Some are, but most are not. And so I think most would probably say, hey, you need more sleep, right? You need to turn your screens off at night. You should eat a more nutritious diet. You should get some exercise. I think most of them would tell you that. But if I can do this real quick, can you let me share my screen real quick? This won't take but a second, but I think it'll illustrate the point really well. And so if we just look at this one thing, and this is just one piece of data. Can you see that on my screen, Jason?
Yep, got it.
Yeah. So this is a cell membrane test, and this is par for the course, actually slightly better than what I'll typically see in an average patient at baseline. And I do not think most primary care doctors are actually looking at this. But what do we see here? So this is the composition of a red blood cell membrane, and it'll reflect about a 90-day average of the fatty acids that were available to populate this membrane and how it's being built, and likely is a reasonable proxy for other membranes in the body, reasonable proxy. And what we see is that this person has a very high percentage of saturated fats in their membranes, 36%. That will stiffen membranes, right? That will reduce fluidity. It also will affect cell signaling. They don't have high trans fats, which is good. But then when we look at their omega-3s, their essential fatty acid omega-3 concentration in this membrane, 2.19%, severely depleted. We're about to talk about these omega-3s and how critical they are in signaling pathways. The EPA is not severely deficient, but the DHA is. They actually have a pretty good level of alpha-linoleic acid, which is another omega-3, which you don't typically see. Usually this is low. And then if we go down, we look at linoleic acid, which is the seed oil fatty acid everybody's talking about. It's an omega-6. It's an essential. It's still important. It is elevated. Most of the time at baseline, these are 1400. And we see a high level of arachidonic acid, which is an inflammatory signaling molecule being produced from the linoleic acid, that the EPA actually does a signaling role of balancing this out, right? And tilting it in the other direction. So with this one test, what do we know? We know that this person has more than likely throughout all cell membranes, a severe deficiency in omega-3s, an elevation in omega-6. The signaling pathways are skewed to pro-inflammatory, even if that's not appropriate for what the system is encountering. And we have a loss of membrane fluidity. What does this translate to? We could reasonably infer, we can't prove, but reasonably infer mitochondrial membranes are unhealthy, not functioning well, likely reduced mitochondrial efficiency, and that globally throughout the body, the membranes are not functioning well, right? So if we don't fix this, then we're ultimately not, with everything else that we try to do, which could be useful and helpful, we are not actually at a foundational level giving this human system a chance to rebuild its health, right? It's compromised right here. Just one simple test that is unlikely being used by the vast majority of primary care doctors right now. That addressing it would make a huge difference in health outcomes.
And let me ask you this. So, and here's, I'm going to associate this with something that has nothing really to do with this, but I think you'll follow the line of thought. So Abby, my youngest that has type 1 diabetes, managing her glucose levels and her blood sugar, you can just dial it in perfectly and still she can have a high or a low. You know, there is no kind of uniform, and there are uniform behaviors that are going to hedge toward a manageable glucose level, but it can also, no two type 1 diabetics are exactly alike on what spikes their insulin and what doesn't, or what spikes their blood sugar, or doesn't. Looking at that kind of that recipe for a healthy mitochondrial cell membrane, is it universal? Like if everyone had perfect numbers to a like if you could just create a perfect recipe for fluidity in that membrane, which we're about to get to exactly kind of the definition of fluidity, is it universal if you just maintain?
It's pretty universal because human cells are human cells,
Okay.
right? Yeah, and so there are subtle variations, right? And it's a spectrum, but what would be optimal in that one is that the saturated fatty acid index was under 30%. Linoleic acid was reduced. The DHA, the 2.19% omega-3 index would probably be a 6 or a 7%, or maybe even an 8%. That would shift the arachidonic acid, right? That would be more optimal. What we didn't measure in that test were the actual phospholipid levels that are available, which we'll talk about as well. But I could show you that same person's initial test that actually measures phospholipid levels, like phosphatidylcholine and phosphatidylethanamine. Those were also severely depleted, which leads to structural instability. And in the mitochondria, a destabilization of something called cardiolipin, which absolutely wrecks mitochondrial function. But yes, generally speaking, there is within a range, there is a universal, recipe for how to build healthy membranes.
Okay. Now I'm going to ask you again, kind of put my disclaimer out there. It might be an ignorant question. Well, it is ignorant because I just don't know. I saw on that one high fats, low omega-3. So in my small brain, I'm thinking, so that would be a stiffer, more hardened
Yeah,
membrane. Would
that's
that be
correct.
correct?
Yes.
Which and why that's bad is because that means more likely to crack. It's not as
Yeah, it's more with the ability of the membrane to be malleable, right? Like to, you
hey,
know,
in our Christian speak, it's old
yeah.
wineskins that burst,
Yeah, yes.
right?
Right, yeah. Yes, and to degrade, and the body is constantly having to
Yep.
turn over segments of that membrane, which also affects something called cell senescence.
Okay.
Cells become senescent more quickly. We can take that up on another podcast. That's a whole topic of its own, cell senescence and how that's impacting things. Membranes are playing a role in that. And there's obviously so much more that I'm not saying that we could say about this.
Okay.
Yeah. Yeah.
But let's talk a little bit about that fluidity though. Like what does that mean? Why does it matter? And again, just kind of, and then we're going to get down into some of your ways that you've solved some of the things that we've talked about.
Yeah, I mean, so with membrane fluidity, membranes are meant to be impermeable. We're not talking about them being porous and open. Membranes need to be impermeable and then populated with all kinds of channels and receptors and different ways of allowing signaling to take place. Some signals are actually taken right into the cell and transported to the nucleus or some other aspect of the cell. And just in case a cell biologist listens to this, yes, the peroxisomes are important. The endoplasmic reticulum is important, right? Like there are all kinds of other uh, organelles performing functions in cells that are critically important. We're just really focusing on the mitochondria right now because that one's sort of like that keystone piece of disease development. But nonetheless, and a lot of these signals are actually based on a receptor, particular type of protein that can receive as a molecule, like it has a specific fit for that molecule, and then it sends the signal into the cell. Now, with fluidity, you're mostly talking about, again, that membrane's ability to kind of because if you look at cells and the environments that they live in, and especially in the brain, they've got to be able to bend a little bit and give a little bit and move, and some cells will migrate. And if they're stiff, you can imagine that's not going to work as well. And as we mentioned earlier, at least in the brain, what we know is that a loss of fluidity also directly impacts global synaptic function, overall brain processing. So we know that. So at the end of the day, stiffer membranes are going to lead to a lot of problems. One that I can speak to directly would be you just simply can't process to the level that you would be able to. And you may not notice that. You may think you're processing fine, but you don't know that you're missing one or more gears of cognitive capacity that would be available to you.
Is that related to aneurysms and brain injuries of
No,
that kind at all?
that's a different thing.
No, so
Yeah.
it has no okay.
Yeah, that's a defect in arterial walls
Okay.
that allows, weakening and outputching and all that. Yes.
Okay. All right. All right. So all of this leads us to how, you and I got together from a business perspective whenever you first started talking about F2 and how you were looking at membrane health. You had this formulation that was in your, I wouldn't have known this, but because you're a practitioner and have been for so long, you were like, it's a pretty simple formula that goes direct to the issues we're talking about. And so we started talking about, hey, let's put you to work. Let's let you go and see what you can develop. And that's how F2, our essential fats formulation, came about. Talk about the origin story of that and how you ended up formulating that to try to solve for some of the things that we've talked about.
Yeah, so several years ago, the epiphany began to turn on for me that one of the first things that we need to start addressing is cell membrane health and integrity in the body, right? Like, if we're not doing that, we're missing a big piece. And years ago, my way of believing that I was doing that, one was dietary corrections, eat less processed foods and seed oils and oxidized fats. All those things are important, but to just supplement omega-3s, DHA and EPA primarily. Right? It's like, okay, let's make sure you have proper levels of DHA and EPA and DPA. And that was a good intervention. But at that time, I wasn't really thinking about the phospholipid component or considering the possibility that there were real problems with deficiency in that area. And I wasn't really thinking about fatty acid derivatives that are playing a role in membranes, like plasmalogens and PEAs and others that are all playing these important roles. And so we were really just like, okay. And then once we optimize somebody's omega-3 index on their cell membrane test, part of the saturated fat problem here, part of it only because this is a person who had insulin resistance and metabolic issues, which increases saturated fat production in the liver, which ends up increasing cell membrane concentration. But the body has to build an intact membrane, has to. And it has to build it mostly out of various fats, phospholipids, essential fatty acids, saturated fats, all this. And in the essential fatty acids like omega-3s and omega-6s are dependent on consumption. Okay. And most people don't have a problem with consumption of omega-6, but they do with omega-3s. So if you don't have adequate amounts of the essentials that you would have had to consume, your body is going to use what it has to build the membrane, which would be saturated fat. That's a fat it can actually bioengineer and produce itself. And so part of that problem, part of the problem for that particular individual is simply increasing the percentage of that membrane that is omega-3, which will reduce the percentage of that membrane that is saturated fat. All right. Now, what I began to learn when I started networking more with brain biochemists who were focused on neurodegenerative diseases like Alzheimer's, Parkinson's, ALS, other forms of dementia, MS, I began to learn more about how important these phospholipid components were. And as I went down the research rabbit hole, it was like, holy cow, right? Like what phosphatidylcholine is doing at mitochondrial membrane level in terms of maintaining structural integrity, what it's doing on the macro level of the outer membranes. I'm like, this is critically important. And when I discovered that there was a test I could assess this with, I learned that most people on first assessment were significantly deficient in these phospholipids like phosphatidylcholine, which does a lot of things beyond just its role as phosphatidylcholine. Now, the people who were eating more ancestral diets or paleo, where they were eating a lot of egg yolks, maybe even liver, taking organ meat supplements, they didn't have these problems because those were the most, that was the best source in our diet, which was prominent in our ancestral diets and has simply fallen off the map in our modern diets. And so obviously there's a food way to do it. So then I began supplementing phospholipids, right? And the plasmalogens, which we can take up another time, which are critically important protectors of the membranes. Plasmalogen depletion is probably one of the foundation steps in beginning to develop neurodegenerative diseases. Well, they're actually built off of the phospholipids. They're derivatives of these phospholipids. So these phospholipids are critical. Phosphatidylcholine is also a source of choline for acetylcholine, your learning neurotransmitter. So I then began to layer in phospholipids on top of the omega-3s, and then diverse forms of vitamin E that are also intramembrane antioxidants, and then retinol, and then for the mitochondria, coenzyme Q10 to be both an antioxidant and support the flow of electrons in the mitochondria, because most people I was testing were deficient because they had an oxidative stress problem in their mitochondria. And so as I one by one was learning and adding to the regimen, so it started with an omega-3 supplement, and then it became an omega-3 supplement and a phospholipid supplement. Then it became an omega-3, a phospholipid, and a fat-soluble nutrient supplement of retinol and diverse forms of vitamin E, and let's see, what am I forgetting? Vitamin D3, vitamin K2. And then what I started seeing, of course, were some significant improvements in those patients subjectively in terms of less anxiety, deeper sleep, clearer thinking, less inflammation, and able to measure that. Now, we were always doing multiple things at once, so I can't prove that one intervention was necessarily recreating everything else. What I can tell you is that Dr. Himal Patel, who's one of the most brilliant mitochondrial experts in the country and a good man, has created a mitochondrial function test called MeScreen, which is really remarkable. And now he's collected a lot of data, and he had recently messaged me and said, now that we've run, I can't remember, but it might be 4,000 studies, what we're seeing is that for most people who have impaired mitochondrial function, it is due to degraded membranes, and that so membrane repair is like the essential first step, and that it's a 9-month process to rebuild it, right? And so that's where this idea of, oh, I'll start this energy improving mitochondrial supplement that maybe has some of these fatty acids. Maybe a lot of them don't. A lot of them will have urolithin A, which is good. I'm not criticizing it. Resveratrol, quercetin, all good, but they don't actually have the essential fatty acids. Most multivitamins don't. And if they do, they don't have it in nearly anywhere close to adequate dosing. And so that's where it was like, okay, if you really have mitochondrial impairment and you start some kind of mitochondrial support supplements, your expectation isn't that you're going to be all right as rain in a few weeks. This is a long game you're going to be playing. Will you feel better early, like sooner? Yes, you will. To get back to what was the fullness of function that should have been available to you, that's months out. Now, in our model where we can bring in peptides that catalyze a faster repair of membranes, maybe we can make that 9 months, 4 to 5 months, right? And that's taking it to a new level. But at the end of the day, what I ended up having was this regimen that my own children used of phospholipid complex, essential fatty acid complex, fat soluble nutrient complex. And then, as you know, with F1, full spectrum B complex, fulvic humic. So we had all these different products and they worked. People felt better and I could measure it on their tests. This is getting the job done. Yet it was a lot to keep up with. And I always had in my mind, if we could create an integrated product that put all of these together and made it easier and more affordable for people, that would make all my patients' life easier. And that's where F2 came from.
And just to kind of like double click on that a little bit. So what you're saying is, because I remember this when we first met, I mean, that, of course, I guess, well, F2 is, I should know the dose since I take it every day. That's 1 capsule twice a day. And
that's right? F1.
That's F1.
That's our water solubles.
There you go.
So F2 is 6 total capsules because it's a lot of different molecules, right?
That's what I'm taking 2-3 times a day.
Yes.
Okay.
Yes.
And so, but 2 capsules 3 times a day. I mean, how many bottle caps did that used to be that you were sending your patients home?
Yeah, it was a lot. Not only that, I mean, with F2, you can do it 3 twice a day. You could actually, if it's with food, take all 6 at one time. You don't have to spread it out necessarily. But yes, it was the original regimen, if you count F1 and F2, represented, I believe, if I remember correct, 8 different products and I think 16 total capsules a day. Now, with F1 and F2, it's 2 products, 8 total capsules a day. So my children were a lot happier. But even with the complicated, like when my girls went off to college with a basket full of all these things, they didn't complain because they knew the difference, the reduction in their migraines, their better sleep, how they felt, their focus. They were like, there's no argument. If I have to open up 8 bottles and take all this every day, I'll do it because I know what I felt like before. But thankfully now they don't have to.
Yeah, I remember I was looking here and Jim Melissa gets on to me because I like the first shopping list you gave me back before we had developed the foundational stack. I still have remnants of that just massive first order of all the things. So it's a shameless plug for for the stack, but nevertheless, I can tell you, real life testimony, it's made my life a lot easier just having to have 3 bottle caps. It's a game changer. All right. So as we kind of start to land this plane, I want to ask you just like some real world applications here. And we've covered a ton. As a matter of fact, I had a whole line of questioning about the A, the D, the E, and the K. You went through that perfectly, the phospholipids, because that was kind of one of the things that was a little bit different. And then why you started, like, it was kind of a novel approach, the way you tackle mitochondrial and membrane health, the way you did. So it's like, this wasn't universally thought of. This is literally kind of Gus Vickery, like you said, starting with one kind of cornerstone and building these blocks. And I think that's important to recognize. And then here's one of the things that I wanted to ask you just for real life application. All right. Is improving your cell signaling more about adding nutrients or removing things that are actually damaging the membranes?
I think it's both and, right? Okay. Like, so on one hand, if your body, and most people right now in America are, if they did a comprehensive intra-extracellular nutrient test, they would find out that they have broad-based nutrient, at least insufficiency, meaning maybe they've got just enough to maintain function, but not enough to put more demand pressure on the system. But most people are also going to measure out with multiple deficiencies. And especially when it comes to B vitamins, particular minerals, as well as vitamin D and essential fatty acids and phospholipids, right? So most people are in that category. These are the essential, and if you take amino acids and throw them in there, these are the building blocks of everything in the body. Right now, there's more to it than this. There are phytonutrients and polyphenols and other molecules that are important, not negating that. This is not a prescription not to go eat real, natural, nutrient-dense food. This is just a way to make sure that you're not missing these essentials with the food that's available to you in America today, which most of it is not as nutrient-dense as it used to be, and based on dietary preferences as well. So the where was I going with all that? I lost my train of thought for a moment.
Well, we were
But
talking about
yeah,
which is more important to the
yeah.
nutrients
So first and foremost, giving the body what it has to have to perform, just to be able to maintain function, that is your most critical foundation step. Like if you weren't going to do anything else, you would do that. But if your body is poisoned, and most people are, with all of the plasticizers and endocrine disruptors and heavy metals and mycotoxins and organophosphates and pesticides, herbicides, and glyphosate that are heavily penetrated into our water, soil, and food supply, well, then you're being constantly poisoned, right? So your body is having to work against that. Now, if you're being constantly poisoned and the very systems that eradicate the effects of poisons from your body that are built out of essential nutrients are compromised, that is just a setup to feel badly and develop disease. But if you're being constantly poisoned and at least you have all the nutrients that you would build resiliency and have systems work, you got a better leg to stand on. But at the end of the day, we have to do both. We have to simultaneously replete nutrients, give the body what it has to have to work, and begin to reduce the poisons, right? We have to do both if we want to experience good health. If you're only picking one, I'd bring the nutrients in. You got to have them. Like you just literally can't build cell membranes. You can't, the proteins and enzymes that you need that are made out of the essential, amino acids, the B vitamins that run so many of the chemical reactions, you got to have them. And if you don't, you're going to begin to suffer. Now, you may not recognize you're suffering because everybody's now used to just feeling kind of washed out and tired. It's just life, but you are suffering. And if you knew what it was like to have nutrient optimization and begin to experience just that alone, you would be like, holy cow, I'd had no idea that I was actually feeling the way I was feeling. I just gotten used to it. And so just fixing nutrient, like back to the dysfunction disease conversation, what I found when I began to really dig in and address the nutrients comprehensively as the model evolved was that for people who had minor dysfunction in their system, and maybe they're a little tired, that would pretty much fix a system, especially if it was the person who wasn't too old yet, and then the people who had more severe dysfunction, we had to do more. People with disease, we absolutely have to do that first step, but there's a lot more we have to do if we're going to get it reversed. And so, I would advocate that everybody, either one, go get an accurate inventory of your nutrient status. What is your food doing for you? Maybe it's doing a good job and you're really not lacking and you have a great gut biome that's doing a good job with its nutrient generation. But if you're not going to do that, then I would use, whether it's the formulations that we've created or something similar, I would use that. A standard multivitamin is not going to provide the dosing and the and the comprehensiveness of the different nutrients. Like in F1, the fact that we have that shiajit, that fulvic and humic, like that is so critical of a piece of nutrient transport. And so it really all comes together and is critical, and it makes a huge difference. And these membranes are critical. And we didn't even get into the documents. I've created a couple of documents for Jason where it was a little more granular, talking about how phosphatidylcholine, EPA, and DHA together as a symphony program these membranes and affect the inflammatory signaling pathways and the oxidative stress pathways and the membrane fluidity and how the and you can make those documents available to most people if they can decode them, but it'll show you that what we're talking about is rooted in hard science, legacy science of how the body was designed to work.
I think with that, so I think today was kind of the why, and maybe that we can do a part two as the how, kind of dig
Yeah.
down into how these things are, because I do think that's important, Gus, especially when it comes to, and we've talked about this a lot before. We could just take the approach like so many folks do that just start talking about a supplement and people get excited because they trust the doctor, they trust the host of the podcast, like they go out and they buy it, and it's, but it's really important to me, and I know to you, that they understand why the heck that supplement ended up in their pantry. I think it's so important. And again, whether you buy ours or not, these essential nutrients and the essential fats and the essential amino acids that come as part of the foundational stack. It's like, I want to be able to go to someone that if they bought it from us, if they bought that stack from us, they go, all right, here, I want to just make me feel good. Tell me why you're taking F1. Tell me why you're taking F2. What's it for? Tell me about mitochondrial health. Don't just do it because, well, Gus and Jason sounded like they knew what they were talking about. So sure, I'll go add that to my freaking budget. And so I think that maybe we do a part two on getting even a little bit deeper on kind of why those things are working. And I think this was a good it was a good refresher for me just to go back and kind of cover these topics that we haven't really gone into in quite a while. So this was good, man. I really appreciate it.
And we're really just at the tip of the iceberg, right, of what we could talk about. And I will be clear that with people with neurodegenerative disease, we don't stop with F2. We add more phospholipids. We add plasma. We have all kinds of stacks. But instead of having to do that, why don't we at an earlier age just go ahead and give the body what it needs to maintain those membranes?
100%. Gus, brother, so good to see you today, man. I enjoyed the visit, folks. If you have any more questions, and if you have decided to check these products out, you can go to shopauthentic.health.com. They're there, and reach out to us if you have any questions, anything we can do to help. I can put you in touch with Gus's clinic, and you can find out more about that. But with that, thanks, Gus.
Thank you, Jason. Always a pleasure.
All right, brother.
The content provided in this podcast, The Healthy CEO, is for informational and educational purposes only and is not intended as a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of your physician or other qualified health provider with any questions you may have regarding a medical condition. The opinions expressed by our hosts and guests are their own and do not necessarily reflect the views of the Healthy CEO. Any information provided by our hosts or guests, including any physicians who may appear on the podcast, is solely for informational purposes and does not create any doctor-patient relationship. Listeners are advised to consult with their healthcare providers before making any changes to their health routines. The Healthy CEO and its affiliates assume no responsibility or liability for any consequence resulting directly or indirectly from any action or inaction you take based on the information provided in this podcast.